Good morning, everybody. How's everybody doing? Okay? It's a little early. Everybody's Starbucksed up and everything. My name is Michael Finocchiaro. This is my friend and co-presenter, Ryan Kuprak. We both work for a little company in France called Dassault Systems, you probably never heard of. We make software that builds things like the big boat that's over next to the Moscone Center. I'll talk about that in a minute. We're going to talk today about hybrid mobile development. So we're going to go into the concepts both of Cordova and JE7 with a pretty heavy emphasis on HTML5 JavaScript as well. So it'll be as you'll see, an end-to-end really nice application that Ryan built for this. So I hope you guys appreciate that. He'll do a shameless plug later, but he is the author of several books, including the NetBeans certification one and EGB3 in action. So question, who wants to be a billionaire or the next Apple Store billionaire, like, you know, the guy from Angry Birds, you know, throwing birds at pigs and all, and Snapchat, and I mean, it's just kind of crazy, right? The amount of money people are making on just simple apps. Well, this class will teach you how to make one of those simple apps and deploy it on any mobile device, because as we know, the mobile market, the smartphone market, is just exploding. The exponential growth in China in particular. I mean, we're talking like 1 billion users, right? Even if you hit 1% of that, you know, you're already one of those guys building Angry Birds, right? So it's a really good incentive to work on this stuff. And as Ryan's going to show you, it's really, really easy. So we're going to go over some of the fundamentals and the basics. We're going to talk about the mobile overview, the tooling that you need, and then we're going to dive very deep into JE7 and Cordova in terms of Ryan's app that he built. And we're not showing this just as advertising for last year's Open World, which actually we went to 2 of the races. It was really cool. But his app is actually, as he's going to explain, managing one of those races. So he built an app, a real app, you know, with real code that could for someone to manage that. And by the way, you probably didn't know that, little known fact, both of those boats were designed with our software, with Dassault Systems CATIA software. Unfortunately, we don't have any logos anywhere near the boat, but it really is that's what we do. We build a software that allows you to build boats and airplanes and cars and toothbrushes and formulas inside of chemicals, which is what he does. And I'm the evangelist for the platform. Okay, so no more work stuff. We'll go right into fun. Oh, and by the way, has everybody gone down to the Moscone and seen the boat? It is super impressive. It's totally awesome. So anyway, little picture there for you. And this is Ryan's slide. Okay, so we're going to be covering many technologies today. We're going to be looking at Apache Cordova, of course, along with Java EE7. Tied in with that, we're also going to be talking a little bit about Node.js, which is required for the Cordova stuff, along with the user interface for the mobile application, which was done using jQuery Mobile. And I picked jQuery Mobile for the demo application for today, primarily because most people are already familiar with jQuery, and some of the other frameworks out there have a steeper learning curve. We're also going to look a little bit at the Android dev tools and iOS dev tools just in passing, because both of those are required if you're deploying to trying to test on a device. And if you're trying to develop for Tizen, BlackBerry, or Windows Phone, you also need those tools as well. The IDE that we're going to be focusing on today for development is the NetBeans IDE, which is probably the best IDE right now for HTML5 development for mobile. I checked out, when doing this presentation, I tried to find another IDE that had as integrated an environment for developing and deploying the applications. I did not find any. There's IDEs like Xcode that are specific for deploying for iPhone or Android, Developer Studio for Android, but there's no IDE that really integrates the entire experience in terms of development for HTML5 applications into one place where you can write the Java code, the JavaScript code, and also push it out to the device. So you know, you can use something like Xcode for developing it, but it won't have as good of JavaScript coding experience as NetBeans does. So, as Michael mentioned, the application for today is the sailboat racing application. I do a lot of racing crew on a boat during the summer. Typically, with you set a bunch of marks out there in the water and you sail around them. So if you were out here last year for Oracle Open World, you'd see the yachts going out and hitting certain marks. So that's essentially what the application is doing. The application is basically distributing information about the course and also tracking the progress of the boats on the course.
Using geolocation, pulling data from the weather service and everything.
Yes. Yep. Yep. So the basics of the application, or how racing is normally done, you have a committee boat that's usually volunteer that goes out there. So every yacht club in the United States has something like this. Committee boat goes out, floats out there, sets the course, and announces it via the radio. The boats also register via radio, so they call in and say, I'm a fast boat, so I'll do racing class. I'm a slow boat, I'm doing cruising class. And then each class of boats gets a different course. And they don't decide the course until they actually get out there. They look at the wind, the currents, and figure out what to do at that point. So it's a real it's an application. There's always this coordination over the radio, and there's always somebody jumping onto the fishing boat and talking about their catch while we're trying to get the course out. So then there's a start sequence for each class, and how a sailing race works is that you have a start gun, and your goal is to be crossing the start line and not hitting any of the other boats just as the horn blows. So it's kind of exciting, and there's actually like accidents. That's why if you sailboat race, there's pretty hefty insurance. So then for each class gets its own start. The boats go out there, and then the committee boat tries to monitor what's going on the course to see what's actually happening out there. Because if the fog might roll in, and they might not be able to see the boat. So that's where this app comes in. Additionally, the wind might die, and the long course that sounded like a great idea means that everybody will be finishing a day from now. And they thought they were going out there for a 2-hour race. And then the finish time for each boat is registered at the end of the race, and the final results are calculated. The boats have different ratings, so most of the boats, when you go into a yacht club, they're not the same boat like the Oracle race out here. So there's a handicap associated with each boat. So even if you finished ahead of another boat, it doesn't mean that you actually beat them. So this is a real application. This isn't like a to-do application or something that's really simple. So there's some real problems with this application. So the functional requirements: the app must be able to broadcast, handle boat registration, time check for start notification, tracking of the boats that are out there, race announcements, results, and weather information. Being able to push the weather information out there so the boats can find out what's going on with the tide. And so you'll note, in terms of developing an application, we'll kind of get into this with the EE7 stuff. We have concurrent asynchronous stuff that's going on here. We have information where the server is pushing the information out to the boats. So this is why Java EE7 is a good fit for this application, for mobile applications. So we'll kind of be touching on this. You'll see that there's concurrency involved. Eventually they'll be tying into the batch processing stuff for processing the results afterwards for the EE7 stuff. So this application is made possible because of Java EE7. It's much easier to write. Okay. And
the architecture is relatively straightforward. We have don't want to trip over that. And by the way, I think I probably glossed over it. All the source code's up on GitHub. I'll show a screenshot later, but you can get all the source code with everything. Of course, there's an infrastructure based on JMS and CDI. The persistence layer is all JPA. We use AJBs for all the actual business logic, the application. And then for the UI, it's Cordova, so we can hit both Android or iOS. JAX-RS for the communication, and then WebSocket for the actual transmission of data. So it's also a great sample app because it gives you almost every feature in JEE all coordinated and working together. And so we have this demo app sitting in an iPhone, which is a single-page app. So even though it's running as HTML, you don't see, as we'll see later, how many bars you got on your phone and the changing pages thing. And it's all in HTML5 naturally. That, of course, is hitting the JE app server with a Postgre database in the back end, because we also forgot to mention this is all running on Amazon. Right? Then that'll be probably our talk next year, really, how do you do the deployment on Amazon. And then, of course, as we mentioned, it's also going to query NOAA to get the weather information so that the guy can cancel the race if a big squall comes up or something. And it's also many, many users, right? Each boat potentially would have a copy of the app, so they'd be looking at it to see what, the instructions and so forth. So it'd be really a huge tool for the guys running the races. And of course, he hopes to be the next billionaire, but just selling to yacht clubs and so forth. And it's a rather complex business model. It isn't just hello world and out, right? This has got a ton of different tables. I think there's over 16 tables and lots of relationships almost everywhere. So it's a real solid, comprehensive data model that you can, again, study for your own personal enrichment. And, of course, as I mentioned, so once again, another plug, you can go to GitHub even now and go grab the source code off of Ryan's repository, so that makes it real easy to get started. And he's now going to demo the application. So.
Okay, cross your fingers.
Yeah,
this is just going to be a
live demo part.
quick demo piece.
Don't try this at home.
Okay. So the server is already running, so that's the N34 server. So the application is N34 Sailor. Let me run the application.
It's going to start the simulator, right?
Yes, so this is going to launch the iOS simulator, which hopefully my aging laptop will kick off. So notice that
on here?
What's that?
Were you able to get it on here?
No, I wasn't.
Oh, okay. That's what you could try at home, is actually run it off your phone.
Yes. And I'll probably be able to run it on the phone later on. As we can see, we're launching the simulator. I had to get my Apple developer account fixed yesterday. So notice, this is all being done with inside of NetBeans. I'm launching, I'm deploying, I'm compiling. It's doing native compilation underneath the hood. So it kicked off Xcode and actually ran the Xcode developer tools underneath the hood to build up the application. There actually is a Xcode project underneath the hood that you can actually open up. And so here we're firing up. Michael, in his part of the presentation, will actually discuss a little bit more, but you can actually debug the application from within inside of NetBeans. Okay. Oh, that's not what I like to see. No, don't do that to me.
Are you using traditional Cordova build system?
Yes, so it is using the traditional. So NetBeans is just calling out to the traditional.
Are there any plugins you use or no plugins?
Yes, there are some of the plugins. I'll show that, I guess, because
For
they
the
have...
IDs and plugins for
Nope, no, you do not have to install any plugins for NetBeans in order
for
to.
Eclipse, nor for the
No, you can't do this with Eclipse right now. There probably are some plugins out there for Eclipse. Yep. So
you just standard and script.
Yep. Well, that is unfortunate.
Control Q it, or Apple Q it and try.
It's a great opportunity to show the debugging function.
Yes. Let's check the console here and see what's going on with the application. Nothing. Not what I wanted to see. Okay, well, I will have to pass on that demo. It was working at 2 o'clock in the morning last night.
We'll give it another shot.
So let me just quite quickly go in here. And so this is the application. The application actually has a main landing page here. And I'll show the code off a little bit later. So this is the main landing page right here. We've got, so after you log in, so it initially hits a login screen. Then you log in. It takes you to a menu screen. The menu screen has a bunch of options for actually, joining an existing race, starting a new race, and doing the rest of it. So the project is a NetBeans project. There's nothing that's required. There's no plugins that you have to install. You have to install the Apple developer tools, the Android developer tools, prior to starting the project template, and also install Apache Cordova. But once that's done, NetBeans is up and running for you. So I'll have to demo that. There's actually a separate demo this afternoon in another presentation, so I can demo it there.
I'll start up on mine because I know it's the older version.
Okay.
So I can show it at the end.
Okay. So that was to be the demo. The application actually does work. So with the question is, for this application, why use Java EE? And I kind of touched upon that before. You have the object pooling, which is one of the important features with enterprise Java beans, which means that you can control the number of stateless beans that are being configured. You have support for concurrency. You can actually control the number of threads that are being created. Every WebSocket call results in another thread being created up on the server. Some of the asynchronous processing that's going on in the application results in additional threads. So using Java EE7, you can control and monitor all of that. And you can adjust resource pooling. So that allows you to evenly distribute the load across your application servers. And also database connections. Transaction management, because transactions are very important. It's updating a large data model. Security, I'll touch on this in the presentation. This application does use Java EE security, and you'll see how I tie into that, because it's a little bit different when you're dealing with an HTML5 mobile application. It also does enforce a good architecture on the back end, so the back end does not end up being spaghetti code, although the JavaScript front end sometimes can become that. And then finally, Java EE7 has a rich feature set in terms of batching and a bunch of other features that I can use. So for processing the results at the end of the race, I would probably use the Java EE7 batching for doing that. Okay, so
So why another reason why we wanted to use Java EE was the features around scaling, right? Where you can configure the number of pool, the size of the pool when we start adding more servers or deleting them, having a minimum so we don't have a sudden drop in performance while we're waiting to spin up some more servers, and also caching, of course, the beans as well, so we could get a maximum amount of concurrency. And so that means we can both scale up and scale down. As I said, probably next Java 1 will do something more specifically on deploying on the cloud, how to do scalability and load balancing. But that's another huge advantage of Java EE that allows us that kind of flexibility for more of an enterprise class application. And if you think about it, if his application goes nuts, right, and suddenly every amateur boat club, he's going to need something that scales relatively well, right? It's just as a developer, you can write things that are not so scalable. But if you're trying to become the next Angry Birds for yachts, I guess you could throw yachts at pigs. Yeah, that's the app you should do. Throwing a yacht at a pig. That I would buy.
Yeah, and kind of tying into that, I mean, right now nobody's out sailboat racing because it's 8:30 in the morning. It won't be till tonight. So there's no sense paying for resources with the cloud stuff this morning when nobody's going to be sailing for tonight.
Okay, so we're already 7 minutes behind. That's why I put those up there. Okay. Okay, sorry, this is mine. Mobile platform. So I think we've all seen that Apple basically kind of erased that little icon down there, BlackBerry. So the market is really, really dominated, of course, by Android and by the iPhone. And that's why we're showing iOS, but we're going to also give a little credit to Android as well. But I think everybody's pretty familiar with these. And actually, a friend of mine was saying, is anybody using Nokia, the Nokia phone anymore that's not a Microsoft employee? We're still looking for one.
Okay, so in terms of the development models, so there's several different development models. I mean, as some of you Cordova developers already know, you have the native app model where you build for a specific platform. So that means if you're developing for Android, you write it in Java. For iOS, it's either Objective-C or now, since they've introduced a new language, Swift. And then if you're developing for Windows, you'd have C# and the rest of it. So that's the first model that a lot of people immediately associate with mobile development. The second model is the mobile web application. So it's a server-side application that runs, the back end runs up on the application server. It serves content to the mobile to the web browser. The user has to actually launch the web browser and browse to your application. So there's a lot of websites that target where you have a mobile application, a native application, then you have a mobile version of the web application for the people that haven't installed the app. These types of applications typically use things like jQuery Mobile, Sencha Touch, etc. You have the responsive and adaptive web designs for designing these types of things, apps that will change between the two of them. Then there is the hybrid app model, which is basically where you take WebKit and you make that the application, and you hide the fact that it's a web browser that's actually rendering the content. You package up the content with the application so that they don't actually have to go to a website, or it doesn't have to be downloaded, doesn't require a network connection in order to run it. Now, Apache Cordova is just one of several different frameworks that are out there. It's also known as PhoneGap, or previously known as PhoneGap. There's ADF Mobile, IBM WorkSite, AeroGear, App Accelerator. I think there's one called Titanium as well. So there's quite a few different frameworks out there that are trying to tackle this, in addition to the cross-platform native ones that allow you to write code in, say, Java and cross-compile into Objective-C. And then there's a fourth model that's not on this slide, which is an application that is both an HTML5 application and also a native application. So you have native application bits. We won't be covering that in this presentation because I could spend an entire day on that, but it is possible to have 50% of your application being HTML5 and the other 50% being code that you've actually written for Android, for iOS, for Windows Phone specifically. So although Apache Cordova, you can write mostly in HTML5, you can still crack open Xcode and code your application in that. So continuing the development models, the native application probably gives the best user experience. The mobile web application allows you to target multiple platforms from a single code base. I mean, you don't have to, as long as your app is just presenting content, you don't need to talk to, the accelerometer, although some of the web browsers support that now. That's a good thing. However, most users do still prefer to have an icon that they tap on, or, as opposed to having to sit there, and type in, like an address for a website. You're at the airport and you need a hotel and you're trying to type in Expedia and then enter in your username and password. And it's because your native applications, you expect them to already be logged in, and I'll be talking a little bit more about security later in the presentation. And then there's the native HTML5 applications, which is what we're covering, which allows you to target multiple platforms from a single code base. And I quote, stress the single code base because you don't have to have a single code base. You could write native code for each one of the platforms where you need performance or where you need an phone-specific feature that Cordova doesn't provide. And you can also write plugins that will behave the same across multiple phones. So it requires development tools for each platform. You have access to the device features, but with some limitations. And I must stress I'll mention it later with the PhoneGap stuff. There are PhoneGap comes with a cloud service that allows you to actually compile your application, so you can actually develop your Cordova PhoneGap application for just one platform, and then upload it to the cloud, and the PhoneGap cloud provided by Adobe will compile it for Windows Phone and give you the necessary executables, so you don't have to have all of those dev environments set up necessarily.
And as we said before, the sample app is a single page app, so it doesn't have the bars on the top and bottom that a browser-based app usually would have. So it's far more immersive, and all the app logic course is being done in JavaScript using HTML5 markup, SVG, Canvas, and WGL for the UI, and then everything is bundled with the app. There's nothing else to pull in.
Yep. And so, in terms of native HTML5 apps versus web apps, the first thing, if you're coming from the Java world, there is no JSPs, there's no JSF facelets. So you're not doing the UI using JSF. Okay, there's no JSF in the picture. And then the other gotcha is there's no HTTP session. So because you're not serving up the content from the server, there is no HTTP session, there is no timeout. In fact, every time the application contacts the app server, it might be talking to, if there's a load balancer in the way, might be talking to a different application. So that's the main thing. So that I must stress. There's no HTTP session. There's no JSession ID up at the top that's tracking your session. You don't have any HTTP session object on the server side to put state in to be shared across multiple servers. So it really is a completely different model in terms of how you write your back-end server stuff. So with that being said, and then as Michael mentioned, it is a single-page application if you're doing Apache Cordova typically. So this means that the index page gets loaded first, and then using JavaScript, you browse, you move to the menu page, it loads the menu page into the divs on the index page. When we then transition, you click on the info link there, we then remove the menu page content for it and insert that that content into the page. So although there's multiple pages out there, you're not necessarily clicking and changing it, moving between the different pages. You're actually loading it into a div on the page.
That's
so,
because of the jQuery mobiles.
Yes, that's
yeah.
yes, yeah. So that's and also
use any other.
Correct. Yeah, and if you're using Sencha Touch, it would also behave the same way. And also that means that your JavaScript code up at the top is executed once. So there's many different frameworks out there. So the one that we're using for this presentation is jQuery Mobile. There's also Sencha Touch, the Intel App Framework, Ionic, mProject, Twitter Bootstrap. You can also use Angular. There's so many of them, it's not funny. So the advice is don't reinvent the wheel with that.
And of course, here's a screen of Sencha Architect. Note that it forces good MVC practice because it keeps you nice and structured. It's very similar to how you do development in Xcode or Android Studio, but it does have a cost associated with it, $400. However, the touch bit is free, as I wrote down here, and so you can download Sencha Touch from Sencha.com, create the initial app structure with the Sencha commands. The only issue, I guess, NetBeans has a couple of hang-ups when it comes to Sencha, but you are able to do that, and it is very tightly integrated to Cordova, which is also an advantage when we're using Cordova.
And so just tying back into that, the Sensu Touch stuff really does enforce a good application structure on you. So if you're developing using that, I mean, it will force you to use MVC. Using jQuery mobile, like I did with this application, is very easy to deviate from that. So now moving on to tooling. Tooling is very important because we're actually looking at handling multiple different frameworks that you have to interact with. So you have Cordova, you have Java EE, you're working with app servers, phone simulators, unit testing frameworks. I mean, you're going to have your JUnit, Arquillian unit tests, and then over on the JavaScript side, you're going to have Karma and all the rest of them. So you're going to write unit tests for Java code, unit tests for the JavaScript code. So you're going to have multiple different frameworks, and that's where the power of NetBeans comes in for this presentation, because NetBeans does support all of these. It does support unit tests with Karma, JavaScript. It does support the JavaScript unit test framework, so it does have integration with Karma and Jasmine. And it also has support for the Java EE7 stuff. So that's why I do that. And with NetBeans, if you've downloaded the latest NetBeans, so if you're doing this, make sure you have NetBeans 8.0.1 because they fixed many bugs, and they also slipped in, so even though that's a minor point release, they actually slipped in grunt support, which is the JavaScript equivalent of Ant. So you can previously you didn't have a build system that was associated with your Cordova projects, although I haven't used that yet because I just discovered it 2 weeks ago. But they've got probably the best support for doing all of this.
And then, of course, we also need the platform SDK in order to build for the iPhone and so forth. And in order to automate the build scripts, Node.js, Chrome, Java 8, NetBeans. Those are prereqs as well. And we can use Maven, Karma, Jasmine, and Grunt. Need to accelerate. We're about 8 minutes over. And of course, you need to have a developer license. You need to go to the Apple Store and purchase, $99 to get that. Here's a couple other kits for the different phones, whichever ones you wish to target. NetBeans has the integration directly for Android and iOS. There's nothing else to do. And because of PhoneGap, as we already mentioned, that also allows you, if you pay Adobe, to deploy that directly into the cloud.
Actually, that's free. Actually, if your app is open source, it's free. So you can compile up there for Windows Phone, even if you don't have the environment for it.
So here's the develop program. I was in euros because I did it, but it's $100. And then, of course, we use Node.js. It's required, but it's only we're only hijacking NPM, so we have the package stuff. We're not using anything else in this demo of Node.js. It's kind of boring installations thing, so have fun with that. It took me a while to install all the bits and pieces. And then, of course, Cordova, which is primarily command line based, but that's a nice integration to NetBeans, and you don't have to worry about the command line anymore. But the initial setup is you do your NPM to grab the packages, and then you use the command line to add the stuff so you can, which build environments you want, iOS, Android, and so forth. And then you can very easily do, even me as not a programmer, could actually create a program and get it running real quick. And of course, NetBeans is directly integrated to Chrome, so I just go to the Chrome store, download the NetBeans plugin, and now I can actually debug right in Chrome as well to make sure the pages are showing up as I think they should. And you can debug in Chrome using the Chrome tools, the Chrome developer tools. That's super convenient as well. And of course, you have the NetBeans IDE, and this is where you need the developer's license from Apple, because it's going to grab your provisioning profile when you want to target your telephone to do it. And don't be an idiot like me and upgrade to Yosemite and iOS 8 where everything doesn't work anymore. And then, of course, you create the Cordova project. I think for the interest of the time, we're actually going to do the demo here, because it's just click, 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 new project, and it just creates everything for you. You'll see that as he goes through all the code, and hopefully if I get it running over there. So like I said, this was just to do new project, and you'd see you just select which JavaScript things. It's not all that interesting, trust me. Not as interesting as he's got to say. So now we're going to go into the more hardcore thing, and we're, like I said, we caught up. We're at 4 minutes. So we're 4 minutes behind, but we'll make it because we want to make sure there's Q&A time. So we're going to go into the kind of the heart of the Cordova bit. So as the history of it, as Ryan was saying, it was originally called PhoneGap. I started developing in 2009, and they wanted to just put wrap HTML5 applications into a native wrapper, so I could put them on any phone and only develop once, target many architectures. Then Adobe purchased it, but then floated it as Apache Cordova, and then kept PhoneGap for the deployment on the cloud. So they just have the cloud build system is over at Adobe. It has a whole bunch of common plugins, so it'll just natively use whatever there's on the phone. So you don't have to learn an Android or iOS. It just picks up right off the phone. So it's really easy. And I mean, this is some of them, and they're right there in the code. So this is another example of what's in Cordova and NetBeans. You have all the different APIs. You just select the ones you want as a plugin, and then you have access right to the camera and everything else.
And I should mention, kind of with that previous slide there, those are the plugins that NetBeans loads in there by default for you. There's many more plugins out there on their website which you can manually add to it by just editing the configuration project.
And you can create your own.
Yes, you can create your own things. So some of the other ones that they have that aren't explicitly listed up here, there's a Bluetooth one, so you can actually buy one of those Arduino modules that supports Bluetooth, and you can actually talk to an embedded device. So you don't have to write any driver code or anything like that for the phone. It supports it natively. So that's the short list of plugins that are supported. So Apache Cordova, some of the quirks with when working with it, the HTML5 apps will not necessarily match the platform UI exactly. You do have these situations like where they roll out a new version of like iOS and you have to wait for Apache Cordova to catch up, and also deal with changes to the app's UI to match or handle quirks in the changes of the platform. Each platform has its own quirks. iOS network information is cellular or Ethernet, so you're not told whether it's 3G, 4G, LTE. You're told that it's either cellular or Ethernet. iOS tells you on startup, fires it kind of late, telling you that you do have a network connection after the application is started. The Windows Phone Emulator reports network connection of unknown. Device UIDs on the iOS are app specific. That is to block tracking. So if you're using the UID thing on iOS, it's just going to give you something that's specific for your application. You won't be able to actually use that to track the individual phone user. That's because Apple doesn't want developers actually doing that. They believe heavily in privacy. The camera is unavailable in the iOS simulator. So if you do need a mobile device in order to actually test that, you have to have it tethered. Altitude accuracy is not supported on Android. Windows Phone doesn't provide the battery level information, and each one of the plugins and everything else has a list a mile long. So it really is, although you can, that old adage with Java, write once, debug everywhere. This is write once and customize everywhere, and it's kind of it gets a little bit challenging because, as I mentioned, with the iOS firing the network application after start, it's just not that the APIs are a little bit different. The delivery of those events are a little bit different. So you do have some concurrency issues that you have to deal with that. And then, so for the creating the project in NetBeans, you just simply load up NetBeans. We would have covered this if we were not running short on time. But you just go in there, you select the Cordova application, and you're off and running. And I should mention that the first two, you can create an HTML5 application and then convert it to a Cordova application later. So you can start off by developing an HTML5 application, and then once you get the UI kind of up and running, or prototyped out, then you can say, you can go into project properties and say, turn this into a Cordova application. And the only thing it really does is it activates that feature, so you're not running that, by default with the first two, you're not running it with it initially. So it kind of speeds up your development time. And in terms of developing mobile applications, I usually start out with an HTML5 application first, get the UI up and running before I begin to bring in the idiosyncrasies of the phone. Because initially you're starting off trying to get your APIs to the server up and running correctly before you dive into actual dealing with interacting with the phone hardware. So you want to get the basic application working, and you can use the Chrome integration with NetBeans to test that initially.
So the code structure, when you look inside of Cordova, you'll have a config.xml, which we're going to discuss later. That's the kind of the index of everything on there. And there'll be platform directories, so for all the things you need for building on Android, iOS, and on Android, that's where you find all the code that's specific to that. And in the www directory, that's where you put all your JavaScript and HTML files. So it's really straightforward from a installation perspective. And
then so when you create the initial Hello World project, so if you go in there and say create me an Apache Cordova, it creates this as the initial template that it gives you. As you can see, you've got some JavaScript call, some UI that's going to get updated from the JavaScript code. Down at the bottom, you call app initialize afterwards. And then the JavaScript code, if you've done any Objective-C programming on iOS, at least for me, this looks very familiar because you've got your, your device ready, your kind of like events, when the application initially starts up. So if you've done any native development, you'll see the, it kind of closely mirrors what you'd see if you were writing Objective-C or Android code. So you've got some of the same events, some of the same structure there. So this code right here, once the device ready is called, then you're ready to go. Then you're ready to get up and running. Then the application is successfully loaded and completed.
And here's the config.xml that has all the metadata about the actual program you're running, the specification, the widget specification, the Cordova specification with the version plus the name that he gave to the app, N34. Like I said, all the metadata. Now there is a cautionary note of this origin down here. You need to be very careful of that you could basically be exposing yourself to cross-site scripting exploits, because someone could use that star and then insert JavaScript code. Sorry. So the default access with that star means the app itself, the client app, could hit anything. So if you get control of that, it can hit any server and infect any other server. So you want to be very careful about that and give it a specific domain that it's allowed to go to. However, there's another gotcha, because things are not the same on the different phones. So you're going to have to, for iOS, you use star name of domain star. For the BlackBerry, it's got something special. So you're going to have to do a little bit of research to make sure you get the right thing in there. But you absolutely do not want to put that star there. That would be really bad. That would be a huge security risk.
What's the default value?
The default is the star.
That is the default, is access origin equals star. So that's something you need to modify. That's what we wanted to make sure we mentioned it, because otherwise you could be really opening yourself to a world of hurt.
So how somebody would actually take advantage of that is that they would type in JSON, edit basically JSON or JavaScript code into like a text field on your application, and then if they can look at the source code for your application. Of course, there's tools out there that allow them to see the actual content of the application on the phone. They open it up, they see that you're doing a JavaScript eval. So now you call the server, it retrieves it back from the database. Some other user actually, they get back the JavaScript code, and then if you made the mistake of calling the JavaScript eval function, now they've inserted their code into your running application.
And they've now
they can talk
using a cross-site scripting, so they can run scripts on other sites and infect other servers, and all hell breaks loose. So you don't want to do that. And then inside of NetBeans, you choose the target, and my target iOS or Android, so you can very easily grab that and then build and run the app. Very, very easy too to grab the statistics on whether the people are there. That you use the different plugins to pull out whether they're online or offline. So it's extremely easy to get all the features on the phones without actually knowing the implementation on BlackBerry or iOS or Android. And of course, you can also grab what kind of device is it, because remember, some of those things are going to be specific device by device. And be very careful. A simulator is not a real phone, right? So it's not always going to give you real life. It's not always going to be predicting live. So you really should be testing this on a real phone to make sure it really does what you think it does. And then you need to test it on both ARM and Intel processors, because they might have different behavior. So like you said, write once, debug many times kind of thing. But just make sure that you're getting the behavior expected on a real device, but don't expect that it's all going to be magic.
And then additionally, in this case right here, we're looking at the network connections. We're able to also get the network information. As I mentioned before, iOS is going to report cellular, and the other phones will actually give you, what type of actual connection it is. Now looking at Apache Cordova, so as I mentioned before, you typically will start with an HTML5 project in NetBeans without Cordova and get your UI up and running with that, test in the simulator. You can actually use the browser in the simulator initially, because that will give you the form factor, so you don't have to compile your application to a native application, deploy it to the simulator, or deploy it to a phone. So you can actually do something where you're running your mobile application on on the local server on your laptop, running as a server, and you can actually test it with the mobile phone, because then you can get down some of the testing out layout and stuff, because with HTML5 that's where you're going to spend a lot of your time initially. Yes.
So I cannot
target HTML5 itself with Cordova?
No, you are. I mean, you are. The Cordova just means that when you add Cordova to an HTML5 application, that means that you're going to build a native application that has a web browser embedded in it. But for simplifying development, initially you can just do your development and debug it in the web browser, right? Because the web browser can render the content. The only thing it can't handle is the additions that Cordova has added for talking to getting accelerometer results and so forth. So it's much easier, in terms of testing initially. I initially developed using I initially started off with an HTML5 application, tested it on the mobile phone and the browser on the mobile phone, and then added on the platform-specific code afterwards and turned it into the Cordova application. So I got the basics working, the AJAX calls working, debugged all of that stuff, verified that my error handling was working. Then I started adding in, camera support and the other hardware things later, because, deploying and running it on the thing. And one of the things that I mentioned, yes?
Would you consider making your own custom plugins, for example, for communication? So you could write that in native code and have that as a plugin to your application?
So the question was whether I would write native plugins in order to do the communications.
For example.
Actually, no, in that case, because HTML5 provides the AJAX, the AJAX and the WebSocket support natively. So I would only write native plugins for other things. There's no sense. That would be a pretty hefty thing to write my own networking code, actually. And then testing in Chrome, as I mentioned, does not equal testing on the device. As I discovered, the initial application I was initially storing, because if the phone loses network connectivity while you're out there sailing, I was going to store the results in IndexedDB, which is the database that comes with HTML5. I coded up everything using IndexedDB, was running with the Android simulator, and then went and slammed it on my iPhone and discovered that iOS 7 doesn't support IndexedDB. So I had all this asynchronous code to handle IndexedDB that I had to rip out. Now, it is supported on iOS 8, but I was not going to make that mistake before a presentation.
Well, actually, we tried it yesterday and it didn't work.
Yes, it didn't work. You actually have to. There actually is a separate download, because the plugins are not yet in the main repository, I guess. So they're kind of like in dev mode, so they haven't been released yet. But I was not going to play with. I did that last year for the iOS and Java EE 7 presentation. I upgraded right the night before I flew out. So that was an ouch. So that Can I Use website, you can go to that and check out all of your mobile browsers, because some of the features you might be using aren't available in all of them. Now, in terms of testing with Chrome, so if you're developing with Chrome, testing initially with an HTML5 application and then trying to test inside of Chrome, your application is going to run into a roadblock pretty quickly, because Chrome is going to say, the content for this page wasn't served up from that server. You can't talk to him, right? Because it's going to try to block the cross-site scripting. So this is actually a JAX-RS 2.0 interceptor, fairly common. And what this does is this sets the headers on the AJAX request, the web services request, to tell Chrome, yes, I do allow somebody that did not request the page to talk to my web services. So this allows the browser to do this. Now, when you're running on inside of Cordova sets up the web browser so that the web browser can talk to whoever. That's why the cross-site scripting stuff that we talked about before with the whitelisting is so incredibly important. But this code here will allow you to write your Java EE 7 application and then test it with Chrome and not have Chrome complain at you, because you do not want to disable that in Chrome. Otherwise, you visit a website and get an ad that will clean out your bank account for you. And then in terms of the plugin, so this is just doing a little bit more in depth with the Apache Cordova with the camera support. Capturing with the camera is pretty simple. You can actually, when you capture, you can either capture to the person's photo album on the phone, or you can capture the picture and also use it in your application. So the picture is captured and basically encoded in base 64, and that's what gets transmitted over to the server. The nice thing is that with Java 8, you now have base 64 support, so it'll make it easy to decode that picture. You don't have to download like a separate library to do that. And then in order to upload upload the picture to the Java EE 7 application, it requires special JAX-RS configuration to receive the multi-part MIME request. So we'll see that on the next slide here. This is the code to actually take the picture. The documentation for Cordova is pretty excellent, so I won't belabor everything on here, but as you can see here, I'm saying I want to take a photo. I want to, where do I want us to be able to save it to the photo album, the quality level, and you pass in a callback, what happens on success and what happens on failure. And on the success logic here, this is not using jQuery mobile. This is just me talking directly to, the server-side AJAX support. So this is actually uploading. This code then takes that picture that you've captured and uploads it to the server. So it's doing a post as expected, and it down below sets the the data as image JPEG base 64. That's what the image already is encoded. So you have to tell the server that you're providing that's what's being provided to it. And if everything goes as expected, it will be uploaded successfully. And then this is the Java side of it. This is all the code that's necessary to handle receiving it. Now, if you remember in the past, you might have had to have downloaded multi-part things from Apache in order to do that. You don't have to do that anymore. This is all Java EE7 code with annotation. So we've just annotated a method within a class that says, the path is /upload. It's a post request that's we're going to receive. Okay, and we're taking multi-part form data. So we've configured the method. And then we're returning a response. I always like to return, although I could return void and it would return OK if nothing happened, I always like to do a response so I can customize it if I want, put a custom error message going back if something didn't quite come out right. And then, the URL includes the boat ID of the picture, for the, from which the thing was taking. And I get a hold of the HTTP servlet request so I can, work through the different parts of it. And so down here, you can see where I pick out the, pick out the picture, I convert it to bytes, and then base 64 decode it. This is not actually going to be the final code because this actually loads the entire picture into memory, and with the newer cameras being like 8 megapixels, this would actually be a bad idea to do on your server. So you want to spin this off to something else to do that. And then sends back the thing, or it sends back a 500 error if it didn't work. Now in terms of configuring it, there's one more wrinkle. You actually have to configure JAX-RS a little bit differently. So you might have seen in some of the other presentations where you can just add that annotation to specify the configuration for the application. If you're doing this type of upload stuff, you're going to have to add, configure the REST servlet because, deep underneath the hood, it's actually just a servlet that's being registered for the REST support for EE7. And so you have to provide it with some information, the multi-part configuration so that it knows, how to handle it. And then finally, as I mentioned, with the this is the splash screen. If the app was working, we'd actually see. Although some of the documentation up there makes it seem like you just edit the config.xml file and you're off and running, there are situations that you'll have to actually open up the specific IDE for the the device the device family that you're targeting. So in this case, you need to you don't have to use Xcode, but Xcode will allow you to actually find where the graphics are. And the icons. So you can't just go in there and set it in the config file. You'll need to find the directory where the splash screens are. It's easier to find it with Xcode. So with Xcode, you can go in there and edit some of the additional properties for iOS, the same thing for Android Studio. Okay, so now switching on to Apache Java EE7. So that kind of concludes the the in-depth on the Cordova stuff.
I think we're at halftime. Click.
Yes, we're at halftime.
Halftime show. Hold on. Very important. There we go. Halftime show.
So we're halfway through here. So hopefully everybody's
23. So we're doing we're only 7 minutes over.
Yep. So
how's the speed? It's okay. You guys are okay. Thank you.
So that's the Apache Cordova side. In terms of how to interact with the phone and everything else. The rest of the presentation is going to be focusing on how do you connect the two of them together. So the Cordova stuff, if you know HTML5, insert your framework and your knowledge, you're off and running with it. So in terms of overview, what's the connection between Java EE7 and Cordova? Cordova applications, as I mentioned before, are single-page applications. The application is actually completely written and deployed with it. So if you write a Cordova application that simply goes out to the web and fetches your application, and Apple discovers that, they're going to reject your application. They like the application to be bundled as an application. They don't want you to do a kind of like a wrapped web browser where you're pulling in content, because that means your application could do whatever the heck it wants and they can't verify it. So anyway, the JavaScript in HTML5 is embedded within the application. The application actually ships with those artifacts. So as I mentioned before, you're not rendering JSP pages that are getting rendered in the browser. It's all JavaScript and HTML5 code. There's no HTTP session, And the other thing to realize is that no network connection might exist. So in terms of what's the connection between the two of them, Java EE7 provides the data in the back-end infrastructure. It handles talking to the database because you're not going to write code that in JavaScript that's going to talk to your database. Java EE7 is providing all that, and Cordova, the Java EE7 side coordinates the application processes. So we'll kind of look over, you have JMS. You've got a bunch of things for coordinating things on the server side, CDI events.
But you said no session. Is the request object, request page, or no request, no response, no session?
No, there's just no HTTP session. So when you're with your typical web application, when you connect to the server, it'll create an HTTP session.
Is there HTTP request?
Yeah, you do have HTTP.
So, and then I can use JSP if I want.
Nope. No, you're not rendering because all the content is already on the phone. The HTML5 pages are on the phone, so they're all there. So the only time there's a HTTP request is when you make an AJAX call to the server or a WebSocket call. So in terms of device connectivity, the two ways of communicating with the server are REST, which is request response mode, and then WebSockets, which was introduced with HTML5 and now is a part of Java EE7, and that allows asynchronous bidirectional communication. So that allows you to, the server to be able to push out data to the phone. So that is in the case of, the typical example that you've probably seen at Java 1 with the WebSocket stuff is like a chat application where, one person types in and broadcasts it to everybody else. That's kind of exciting. The other benefit to WebSockets within the context of this application is this application, remember, is going to be jamming GPS coordinates from the GPS on the phone down to the server. Right? So as the boats proceed around the course, you're sending the GPS coordinates of where the boat is. Now, if you do that with AJAX, every time there's an update on the GPS coordinates, every 30 seconds, you're going to open an HTTP connection with those gigantic headers. You're going to send it down to the server. The server is going to then open up a database connection and save it because remember, it's stateless. WebSockets are not stateless. They're a communication that's open for the entire duration until either the connection is lost or one side or the other closes it. So that allows you to stream data back and forth. So in the terms of this N34 Sailor application, it's always using the WebSockets to send the GPS coordinates down so that we don't have to incur that high penalty of opening and closing a connection every 30 seconds. And then if you're writing a game, you can actually do bidirectional. So one of the other uses for WebSockets is like in games where you want to be able to send game updates down. So then kind of a little bit more on RESTful client-server communications happens over HTTP, most often using REST. Although I put HTTP up there, it practically always should be HTTPS. You should never be using just raw HTTP. REST are stateless, which that's the reason why doing, streaming over the, that's why for the GPS coordinates you want to use WebSockets, because every time you'd have to get your database, session back and stuff like that. It is lightweight and highly scalable, so you have no necessarily affinity for a specific server. So if you're in a clustered environment, any one of the nodes can go through the load balancer and it doesn't matter. XML is occasionally used, although practically everyone uses JSON, and this is critically important for a mobile application because browsers are, even though phones have come a long way, at last check the heap that's available to the web browser for JavaScript is still in megabytes. It's not in gigabytes like your desktop machine, which means you don't want to be shipping down XML, which it then has to parse. So the client, in both cases, WebSockets and REST, the client initiates the connection. The difference is that with WebSockets, the server can send the data back. And then with REST, you have the commonly supported HTTP verbs, get, post, put, delete, options, head, etc. And each one of those should map to something in your application. So for instance, with a sailing application, creating a new account is done via a post. Updating an existing account is done using a put. You want to kind of maintain the REST type thing, keep your API consistent, and the IDs at the end of them. And then it uses the existing web technologies and security standards. It's fully supported by Java EE 6 and 7, although there's some major enhancements in 7. Now WebSockets were introduced with HTML5. There's a good tutorial up on HTML5 rocks in terms of how to use them. That's a pretty good site for just learning more about it. It offers, as I mentioned, full true bidirectional full duplex communications. So this means that any process up on the server, once they have access to the session object, can send data back down to the thing. It's not a request response where you send data, then the server sends data back, you send data, then the server sends data back. Both of them can be sending data at each other asynchronously. And you can have, using the new concurrency utilities in Java EE7, you can have multiple threads up there streaming data back to the web browser. Okay? So for the committee boat, they're going to want to see, a stream of data coming back with the locations of all the boats on the course. Now with WebSockets, it is not a new communication protocol. The initial handshake is done over HTTP, which means that this is fully compatible with your proxy servers and all the rest of it. You don't have to punch holes in firewalls or anything like that. It'll just work. So it's perfect, as I mentioned, for games like chat, for applications like chat and games. It uses existing web technologies. The one caveat is that the data is transmitted as Unicode, which means that if you're using WebSockets to upload images, the images are going to expand. They're going to take up a lot more bandwidth because the transmission is using Unicode. And then the prefixes are either WS or SS. And I'm so upset that we can't do the demo, or the demo wasn't working because I have, the Google Maps in the application that allows you to see the boat, because you can simulate that with the iPhone simulator. And then the data for both REST and for WebSockets is typically JSON. So with JSON, if you're not familiar with it already, you have two data structures, objects, and arrays. The types that you have available to you are numbers, strings, true, false, null, etc. It's extremely compact. I mean, if you look at this, I had the stat somewhere on the difference in terms of the amount of space actually was in the book. The size difference in terms of the number of bytes between JSON and XML. So it's pretty substantial. So JSON is much easier to work with. Now, in terms of Java EE7 support, the two containers right now that are out that support it are Glassfish and Wildfly. TomEE is coming in 2015, I believe, as well as WebLogic on the commercial side. So there's more coming soon. Java EE7 was released last year, so it usually takes the containers a little bit to catch up. Some of the major features that we've touched on are the WebSockets. They've also added, which we'll be using today, the JSON API for JSON processing. Concurrency utilities, batching, the JAX-RS stuff. There's also upgrades to JASPIC, which we'll be looking at a little bit later in the presentation for security. Now, in terms of the layers for the application, layers that we're going to be focusing on are the JAX-RS WebSockets, JSON API for Java API for JSON, and JAX-B, and the Cordova is of course running up on the top. But it builds upon all of these. So these consume EJB3 services. We're using JPA, JMS between it, JTA. So all of these are basically being used along with bean validation.
Shameless pitch. His book is in the bookstore. That covers all of it.
So up here, as you can see, we have the JAX-RS. We've got the mobile application, and we've got JAX-B and the Java API for JSON in between, doing the POJO to JSON mapping. And I should mention that with the JAX-B stuff, that's kind of container or implementation specific in terms of the JSON support. So you have Jersey out there, which has a set of features. You have the other one, Jackson, you might be familiar with. And with Java EE8, they're going to be working to standardizing the mapping between JSON and Java objects a little bit more, formalizing that a little bit more. In terms of connectivity technologies, we've kind of already covered both of these, but the RESTful web services, both are basically the two technologies that we've covered already. And they used, for the RESTful ones, we're going to be using JAX-RS 2.0. And then for WebSockets, the Java API for WebSockets. So that's where the two of those map into the Java EE stack. Okay. And so with REST, JAX-RS 2 is the REST API for Java. It received a major upgrade with Java EE7. Important is that they included a client API now. And that client API, when this application was developed, the client API was used in the Archillion tests to test the web services, right? The RESTful web services. And then after they were working with Java, because the nice thing with the Java API is that I can get the Java objects that I return the Java objects that were converted into JSON with the client API, I get them back as Java objects again. So it allows me to do the initial testing and verification and kind of sanity checking of the web services first before I go over into JavaScript land and try to deal with some of the idiosyncrasies over there. They also have support for asynchronous, the interceptors, which were mentioned before in terms of handling the curs things. It integrates with JAX-B, at least I think that's specific to the implementations. It's annotation based, so it's pretty easy to get going. You just take your Pojo and you add your, is the method taking a get, a post, a put, delete, etc. It's pluggable and extensible. And we've already seen an example, but this is another example with a post for joining a race. So we're creating a new entry for the race. And as you can see here, we're grabbing in this method. I specify that I want a header parameter as a part of it. I get my path parameters off the URL. So the parameters are pulled in off the URL that is given. So the container dices them up and gives them to me. And then down below, I can return my response back and forth. So the ultimate URL down at the bottom is the N34 application, race up at the top because that's what the parameter, the path is on the class, and then join on this specific method, and then the ID and the class of boat that's being registered. Now, in terms of passing parameters in, you've got several different. So you've got 6 different types that can be extracted. You've got query parameters, and you can pass in a default value if it's not provided. Form parameters for post requests. Now, if you do like a form parameter, it's going to require the URL encoded. You can get cookies, you can get headers, and then if you're not familiar, there's also support for matrix parameters. So there's some pretty, if anybody's interested, there's some pretty good explanations on what exactly matrix parameters are, because not a lot of people actually are familiar with those. Those are usually like semicolons in the URL. It's a bit different. Now, REST in the Cordova application, to make it easy, the examples in this presentation use jQuery so that I don't have to deal with any idiosyncrasies between the different browsers. It kind of standardizes. It's got a very nice API to work with in terms of handling callbacks. So this is invoking that service that you just saw in the previous slide. So this is the code that joins a race. And you can see where I set the header information. We'll touch on the headers in a little bit. So JAX-RS uses JAX-B for the JSON to Pojo conversion. That's not, I don't believe, explicitly defined in the specification right now. JAX-RS also integrates with bean validation. So what this means is that if you're familiar with bean validation, where you can add your annotations to your Pojo, you can verify when an object is sent, when the framework converts an object to, when it converts the JSON to a Java object for you, you can use bean validation to verify that, to do validation on that Java object. So you're only getting passed in a valid object. Otherwise, the container will intercept it beforehand and kick a error back to the browser saying, you've got a problem with the data that you passed in. So this means that your code here doesn't have to have a gigantic long thing where you're doing validation. Is this field null? Oh, that field was too short. You don't have to do that. That's already, the framework handles that for you.
Can you do that with the WebSockets?
No. I wish.
Yeah.
So that's where that valid annotation comes in. And then on the actual DTO that's being passed back and forth, I've specified that when you're creating a new race, that it must have a future start date, and that I want the name to be not null. Okay? So when this method gets invoked, the JSON will be converted into a Java object for me. Bean validation will be called, and I will only get a race object that has a future date. So in terms of bean validation annotations, you have a bunch of them to choose from by default. You've got the future, the max value. So this is standard bean validation. There's no surprises here with anything with that. And of course, you can also do custom validators. So this one is actually from the sample documentation from Java EE, from the Java EE website. And this is one that I think should be built in by default, but it's one to verify that the email is valid, that the user's provided a valid email. So you can define your own custom validators. You can even do multi-field validation. So if this field is set, this other field must be set. So you can write validators for doing that. And then all we have to do on our Pojo is add email, and then that'll verify that the email address that the user's provided is valid. And I've left off of these just so that they would be readable. You can also provide validation messages specific for these and tie those into a resource bundle, which will be detected based upon the request, so that the user will get back the correct language, for what what the browser, what their phone is running as, right? So you don't have to build in separate support elsewhere to handle localization. Okay, now this is very important with the JAX-RS stuff in terms of it converting stuff into JSON for you automatically, because you saw before where I could return back a Java object back, or actually I didn't have that, wasn't in the sample, but you can return Java objects back, and the JAX-RS stuff will be nice and convert it to JSON for you. Now, when using JPA, you might have noticed that I was using DTOs, and I was like, why am I using DTOs and not returning just the race object? Why did I create a race DTO? And so forth. Well, so this race object, if I return this implements serializable, and I've got a list of the race participants as a part of it. Now, the list of race participants have a reference back to the skipper, because as I mentioned before, this is a complex data model, and I'm using JPA. So it's got a reference back to the skipper, and then the skipper has a password. Now, if I'm not careful and I just use JAX-RS and say, yeah, return the race object, it's going to go through and be very nice to me and serialize everything back and send back a list of everybody participating in the race with all of their passwords. So you want to be, so that's why this application uses DTOs. Now, you might see other demos during the course of the Java 1 where they're, returning Java objects back. So, it's nice, it's converting it back for you, but just realize that if you're combining this with JPA, you might be returning more data than you expect. So, give me a list of all boats. Give me a list of all the boats that are participating in races this weekend, and you get a list of everybody's password in the system. So that's where using that. So you either use, I like to use data transfer objects, or you can annotate it with XML transient. I prefer the first one because you know that if somebody's coding something, they've got a defect you're shipping tomorrow, they're going to go in there and add it and not realize that you just streamed back all of the data to the client. And then the other thing that's fairly important that you can use this provider annotation here. So you want to compress the JSON responses. So even though we're shipping back JSON, which is nice and compressed to begin with, we also want to take and gzip it, right? And we'll set the header to gzip. So this means that after all the JSON is rendered by the JAX-RS service, this basically intercepts the response on the way back to the mobile phone or to the web browser. And all the web browsers support this. We take and we gzip it so it's compressed even more. And the browser will, there's no JavaScript, you don't have to write any code in JavaScript to handle this response back. The web browser will automatically say, oh, the content came back as gzip, I'll convert that back and, I'll ungzip it for you and then, give it back to you as JSON. So this makes a big difference, especially when you're dealing with mobile phones, which might not have the best of connection to not only use JSON for compact data representation, but also to gzip it so that it's even more compressed. And this is all you have to, in order to, to handle gzipping, this is all you have to write. You don't have to do anything additionally, right?
You just have to add this class, right?
Yeah, you just add this class, and with the annotation on it, it'll be picked up, and you're compressing your output. Now, during development, you'll probably turn this off because you'll want to use Wireshark to figure out why something failed and to look at the content. So during
if you transfer little data, you don't need it because performance, takes some.
Yeah. Yep. So you can conditionally. This is a fairly dumb one. This will say, everything goes back as JSON.
Large data, it makes
yep. Now moving on.
A loop with small files, that would be really bad.
So moving on to WebSockets, it's a high-level declarative API. So the Java API for WebSockets is a high-level declarative API. The API is similar on both the Java and the JavaScript side, so the code looks almost the same, especially if you're using the annotated endpoints. So the important pieces, you have the server endpoint, the on-open, the on-close, on-air. You have a session object which is used to send messages. This is not the HTTP session. This is the WebSocket session. You also have, some other major objects are the remote endpoint, which is used to send messages to the client. The message handler interface used for processing messages. It's pluggable and extendable, uses encoders, decoders. It does not use the JavaScript support that we saw previously where objects would be automatically turned into JavaScript for us. We actually have to handle doing that ourselves. So this is a simple example for the committee boat web service. So here we have an on-open, an on-message, on-close, and on-error. And we register our decoders and encoders up at the top, which I'll have more of an in-depth example later on. But this is basically is what the Java code side looks like, and I thought the next slide was the JavaScript code. But the JavaScript code looks almost exactly the same. Now remember, you get called first with the onOpen, and then after that, until the connection is closed, the onClose is called. And then for every time the web browser sends a message to you, the onMessage gets called. And that happens asynchronously. So it's not like where you're not like running on a common thread, where there's a request coming in. And then one other important thing to note is that the on error does not mean that the connection is closed. It just means that something went wrong in the processing. So don't assume that because you got an on error callback, you have to actually check the status of the call at that point, but don't assume that when you get on error, the connection's been lost to the client. No, the on close will be called when you lose the connection to the client. Okay. In terms of parameter types, you can take two different types of parameter types. There's either text or binary. With the annotated one, you can have text and binary or text and binary, but you can't do two of the text up above. So if you have one on message that takes a text, you can't have another one that takes a Java object and use decoders for that, because it's going to convert everything into text. And then you also have, you can pass up byte arrays, and you can have it where it segments the byte arrays for you. Down at the bottom, there's something you'll notice in the API called Pong messages. If you look at the JavaScript code, you won't see any references to Pong messages. And what Pong messages allow you to do, which is on my to-do list for this application, you use Pong messages to basically it's kind of a ping and a pong. So the server sends back, I think, a ping or a pong, and then the web browser, without you having to write any JavaScript code, replies back to that. And so you can kind of send data back and forth to get an idea of what your latency is, for instance. So that's the purpose of the Pong message. In fact, I think there's a WebSocket book over in the bookstore just on Java EE7 and WebSockets, and they talk specifically about how to use this. And then the code for WebSockets is basically the same thing as the one for the Java code. And as you can see here, the client always creates the connection. So here you pass in the WebSocket connection information. You have your on, open, on error, and closed. Looks basically the same thing. And then in terms of how to send a message, so this is the JavaScript code. So I create my JSON object and I stringify it, and I send it. So that's how I would send JSON over to the server side. So this is pretty straightforward.
Only 17 minutes over.
Ah, okay. Great. And so the difference between REST and WebSockets, and hopefully this animation works correctly, is that with WebSockets the connection is always on, whereas with REST, clients are connecting, they're disconnecting, they're connecting, they're reconnecting. Some are going slower and faster than others, but load on your server, what's going on with it. With WebSockets, it's a constant connection, so there is an object that's tied up, there's a socket that's tied up until the connection is closed.
You had said that this was layered on top of HTTP, right?
Yes.
So does this mean that it requires HTTP 1.1 and pipelining to the firewall?
Yes, I believe it does, yeah.
Yeah, the protocol, you have to open for the protocol WS.
Yes, so you have to open up with WS, and then there's a connection upgrade, which I'll have a slide on.
Have you said there is some specific plugin for Cordova for WebSocket?
Nope, WebSockets are HTML5. So
But in some phone, I remember Android had problem with Cordova.
okay.
Not today,
Okay, I'm not aware of that. I didn't have any trouble. I haven't had any trouble with it. Now the support has gotten a lot better the last couple of years in terms of the WebSocket support, but I'm not aware of anything. So anyway, so you're yep, okay. Yep. So with the WebSockets, the important thing to understand is that the impact upon your load, because you are tying up a specific node. With the REST stuff, you can have multiple servers, you can spin up servers, spin down servers in Amazon, but with WebSockets, you've got a constant connection. And as of right now, it is your responsibility to handle failover. So if one of the servers that's servicing a request goes down, it's your responsibility to have used like Hazelcast or some kind of distributed cache, so that when the client reconnects, he can get his data back, so that you're not caching everything in memory. Java EE7 right now does not provide that for you, does not provide the session failover for the WebSockets. So it's up to you to do that.
So you keep the sessions
So yes, yeah. So you can keep the session in memory so that other objects can send stuff back. But if the connection, but any data that's associated with that connection, if that server goes down, you want to be storing it like in a distributed cache, so that if that physical box or that machine that's running, that VM goes down, the data is in a distributed cache, so that when the client reconnects, all of his information is available, that it wasn't lost. And then, as I mentioned before, the HTTP stuff, it's a handshake request, so this is the initial request going up, and we're saying, upgrade the connection. As you can see here, I was using the web browser for doing this, not an AJAX call, because we have the JSession ID as a cookie, which you would not have if you were doing this from an AJAX call in Cordova. And then the response back, and there's like a whole thing with the codes, authenticating the response back and saying that yes, the connection was upgraded successfully. Now, there's two types of WebSocket endpoints. There's programmatic and annotated. Annotated are the much easier ones, and any POJO can be annotated. Programmatics are much more powerful. Touching on objects, I've mentioned the WebSocket session class. So the session is the most important object. It represents the connection to the client. Despite what it may say, you do not have raw access to the actual Java socket underneath the hood. Okay, because the server might be implementing it using NIO or something else. So you've got this abstraction which abstracts out the socket connection. There's very good reasons for why they did that for scalability. So that provides key methods for sending messages back to the client, closing the connection, storing state, so you can actually store state in it, although I don't know if that gets replicated, acquiring the principal information, etc. Okay, and then the remote endpoint is retrieved from the session, so using this you can get an async or a basic one, which is synchronous. And so as you can see here, you have the different methods for sending binary data, sending objects back, and a whole bunch of things. Now, if you use a send object back, it'll use the encoders to figure out which object to encode. The message handler, so you have two different parts. There was an interesting discussion yesterday during the WebSocket session, towards the end of yesterday, where you can't use lambdas with these as of right now. There's some flaw. I guess I have to redesign the API for it. And so this is a more complicated example, registering decoders and building it up using the programmatic endpoint, which are a bit more work. And then you have, your chat endpoint with the on open, on close. Won't belabor that. And then finally you have your on message, which handles processing the message. So this one right here just does your standard broadcast or broadcast back. Now, the one thing with this code right here, although I'm looping through the sessions that I've connected, if you're running and many of the code samples, you'll see that implement chat for the chat application on the Java EE7. They always assume that you only have one node, right? Because if you had multiple nodes and they're each connecting to the different nodes, like in a typically load balanced clustered type environment, you're only going to be sending it back to the people that are actually connected to that server. So this is where the rest of Java EE7 comes in, that you're going to need to use JMS. So if I'd put a JMS, put it into a topic, and then each one of the nodes that has WebSocket connections connected to it is going to send the message back if I'm trying to do a broadcast. So for this sailing application, you have, say, 10 nodes, it's a busy night, you've got 10 different nodes up on Amazon up and running with the application. And then you want to send out a broadcast. Now, each of the races, even though there's multiple races going on, there's going to be users for each one of those races connected into, maybe 9 of the 10 servers. So you're going to publish a message into a topic, and then you're going to have a message-driven bean on each one of those servers reading out the message and sending it back to the WebSocket clients that are connected to that server. So this code here is actually kind of bad because this is not doing it.
Concurrency problem on the specific server as well.
Yeah, because
over the sessions.
Yep. Yes. Yeah. Well, no. The API itself is thread safe, I believe. But this one would actually have some bad because I'm getting the basic one, so it's going to send each one of those messages synchronously. So you want to use the asynchronous one. So yeah, so you get into some really, when you start dealing with this stuff, you're now dealing with threading. So now you're dealing with some heavy threading stuff where you have events kind of coming in and going. Now touching on to the Java API for JSON, this was defined in JSR 353. It provides the ability to parse, transform, and query JSON, so you can use it to create or read JSON. And you don't need to download a separate library in order to do this. It comes with Java EE7 containers. It does not perform JSON to object mapping, so it will not take your JSON and convert it into a Java object for you. is useful for hand coding JSON. So previously I was showing you code where it would take my race DTO and convert it to JSON for me. But very often you might be interacting with a web client where they have where there are custom requirements for the JSON that are going back. We're letting Java return whatever it is and telling the web developer, oh, the app developer, well, this is what Java EE7 is returning. Deal with it. Might not be an option, right? So this is where, especially if you're dealing with things like versioning, which I don't get into in this presentation, but you're going to want to version all of your, I'll touch on that. I'll mention it in the summary, but you want to make sure to version all of your web services because users do not necessarily update your application. So if you're a Cordova application, you're going to want to handle and support where you check the version of the app, the version of the application against what the app server is doing, and you have different versions of the RESTful web services for different versions of the applications, and you have logic in there to handle if that version is no longer supported in the Apache Cordova application. So you're going to have to implement all of that yourself. And then the APIs for this has got two different API models. It's an object model, which is like DOM, and then the streaming model API, which is like SAX. And then for this application, for this WebSocket application, now basically I use kind of like the command approach, where there's different message types that are coming over, right? So I've got an abstract message, there's a chat message, a tracking message, and then a race message. And the race message is like, the race has started. So when the race starts, there's actually, I use the Java EE7 scheduling support, because you can actually have events fire at specific times in Java EE7. So that, when a new race is created, a start horn and a warning horn and a start horn timer is created on the server using the Java EE7 APIs, which are, and then that results, when that fires, a race message is then sent back down to the client, and the race messages can also come from the clients. But anyway, so that's the inheritance hierarchy for the messages that I'm using. So I have different messages, and so each message, because remember with JSON there's no additional metadata, I include the type of the message along with it. Right? And then on the server endpoint, so this is the server endpoint, I'm actually using a stateful session bean, and I'm combining that. So the WebSocket endpoint for a participant in the race is a stateful session bean. We've got our decoders registered, and the reason why it's stateful is because I'm using the Java EE, the extended persistence context, right? Because I'm going to be receiving GPS updates that I want to stick into the database. So I don't want to be, every time a request comes in, let's go out and fetch the user again from the database and update the record. So I want to leverage the extended persistence context that comes with Java EE. So that's why it's stateful. And we have our decoders and encoders registered up at the top. And so we have a tracking message, and I'll show the decoders next. But then as you can see down here, my onMessage takes an abstract message, and then I can either use a command pattern or do an instance of for each one of the message types and process it appropriately.
Why wouldn't you have multiple endpoints instead?
Well, because the abstract message, the reason why I couldn't is because it's the API. As I understand the API right now, and it kind of can vary between the different ones. That's a text. Remember I said you have two different types that you can have. You can have a text and you can have a binary, right? So this one is your text one. So the implementation, if I tried to have different ones for each one, it might not work because it's going to say, well, you already have one. You can only register generally two on-message handlers in the class. It's a little vague. So I've tried to play it safe with that. So our decoders are registered up at the top, and then the message object down below. That's my understanding of how the API works right now. And then our chat message encoder. Now notice I have the encoder takes an abstract message type, and then the decoder. So yes, this is code sample is a little bit old, but one of them they both take the abstract message. So the encode method encodes it to the type setting. So this is how to write out using the Java API for JSON. How I create the JSON. So I create a object builder and then add my attributes to it, and then convert it finally to text and return the text as a part of it. Oops. And then decoding it. Once again, it returns a chat message down below. So the decode method returns a chat message down below. And there's also a will decode up at the top. So that gets called first. So when it's trying to figure out which decoder to use, it loops over each one of the decoders, passing in the message and saying basically, can you decode this? Can you decode this? And the first one that says yes wins. Now, theoretically, you can actually cache the the content because you've already pre-processed part of it. So you'll probably want to, if you've gone through, like in this case right here, this is kind of a bad example. I've parsed the JSON, and I say, yes, I can return, yes, I can process this. Then I throw that object away. Then what's the first thing I do down below in the next method? I read it once again in. But this is not specified in the specification as to whether this is safe in all the implementations, although it probably is, because they might be pooling the coder. So the one that gets called with the will decode might be different than the one that it might be a different object that then gets called with the decode. So it's something to be aware of. So this is basically what I just said on the previous slide. And one thing to note, exceptions in the message processing can wreak havoc. I had, in terms of writing the application, some of the worst problems I had in debugging things were when an exception was thrown in this, because kind of a newish feature, I had trouble getting errors back to the client to find out that, I generally what would happen was I wouldn't get an object call. I'd send an object over, it would blow up, and then my on message would never get called with some of the behaviors that I saw while developing the application. It was a little frustrating. So in most of the encoders, I have a try catch throwable to try to catch anything that blows up right now, just to be safe, so I can do that. As I mentioned, the WebSocket can be a singleton or a stateful session bean. With the stateful one, you can use the extended persistence context. And this line right here, the annotate on close on error, you would not use that with the on. You'd only do the remove with the on close. So if it's a stateful session bean, that's your WebSocket endpoint, your on close is going to be annotated with the on remove to tell the container that the object is no longer being used and it can be tossed away. Right. So otherwise the container would have no idea when your stateful session bean is no longer being used. So it would hang around in memory until the server gets shut down, or there's until you have like another timeout configured. The limitations on stateful session beans, you cannot receive CDI events. So initially, when I completely forgot what was in the spec, I thought I could broadcast CDI events to to all my stateful session beans, and that does not work. I had to use something else. Actually, every time when I tried to use CDI events with it, it would try to create another stateful session bean. So the WebSocket session can be accessed from other threads to send messages to the client. So a couple of things. There's no compression supported by default with WebSockets. The binary data is transmitted using base 64. Don't use WebSockets on the main login landing page of your application, because if every time somebody, you don't want somebody, opening up your application and leaving it there and having a socket connection. So in terms of this racing application, only when you say join race and the race is about, and we're near, like within 10 minutes of starting the race, doesn't open the WebSocket connection. There's no sense in, tying up servers waiting for nothing, right? WS can be easily sniffed and packets injected. Each message can take upwards of 2 kilobyte header, which is much smaller, believe it or not, than a RESTful service call, so it is extremely compact. So if you're transmitting data, lots of data like I was doing, this is a really good way to do it. The WebSocket connection is different than the HTTP connection limit. This means that your web browsers can open up thousands of connections to the servers, which makes it easy to write something that does a denial of service attack in JavaScript. So you can have a little loop there that sits there opening up, I think like 2,000 WebSocket connections to the same server in Chrome. So that's something to be aware of with it. And then WebSocket stuff will suffer, in addition to, this new denial of service thing. Because remember, with an AJAX call, you can only make like 1 or 2 AJAX calls at any given time to the web server. The WebSocket connection, you can open up 3,000 of them from the page. So that's where this cross-site scripting becomes very dangerous. And we're slowly running.
You're back to 3 minutes late. So
okay. That's good.
If you click, it'll be at 10 o'clock.
Okay.
It's 10
Okay. So I went through that a little fast. Okay, so jQuery mobile. No, not 15 behind. So in terms of developing, you will need a mobile framework for doing this. Although it's HTML5, you open up Xcode and you see all of these predefined widgets for you. So if you're starting out without using a mobile framework, you're going to be writing a lot of code trying to get things to look right, because just, you'll end up, if you don't use something like that, you'll first have to come up with your own UI. The reason why I use jQuery mobile for this presentation is most people are familiar with jQuery mobile, and it's optimized for mobile devices. jQuery mobile requires jQuery, so it's built on top of it. It also has support for touch, which a lot of developers aren't familiar with. If you've developed desktop applications, you're not necessarily used to dealing with touch. And then in terms of NetBeans, makes it really easy to install it. Remember, you're going to package the libraries with your application. You're not going to use a content delivery network in order to download them. So in terms of adding it to your project, NetBeans makes it relatively simple. You just go in there and click that you want to use jQuery mobile, etc., and it adds it to your project for you. And then just kind of a quick introduction. So this is what the typical jQuery mobile page. We've got our data role, which is an HTML5 thing, and then the value of which is content. So the content is the section that's going to get replaced every time you click on a link and move between the applications. So although we can't see the application, that's what it looks like. So this is the main menu of the application, and that HTML there, that's what it gets rendered as. So we have our nice little thing across the top with the back, with the log out button, and then we have our individual menu items. So those are all links that result in another content page getting loaded in. So that is why you want to use a framework like SensuTouch or any of the other ones that are up there, because you don't want to have to, because you don't want to have to try writing the CSS and all the rest of it to turn it into that, right? So that's why you use a mobile framework. And I did this using jQuery mobile, but the one that I really liked was SensuTouch because they have support in there for device profiles. Although there's a $400 license for the editor and there's a substantial learning curve, they've got the concept of device profiles, which allows you to have a different layout for your application depending upon whether it is an iPhone or an iPad. Because if this is an iPad application, this menu is not going to take up the whole screen. It's going to be along the left-hand side, and you click on each one of these, it's going to replace the content over on the right. So that's one of the characters, something that you'd want to look at for your applications to realize with your Cordova application, the UI is going to be different. It's going to have different, it's not just, sizing it differently depending upon the width of the screen. You're going to physically lay it out differently. And the SensuTouch also has something that I like coming from the Java world, which has got the concept of layout managers. So you're not just dealing with CSS stuff all the time. So changing to another page, you've got the mobile change page, mobile.change page. This allows you to, in JavaScript code, to transition to the next page. And then you've got callbacks for each one of them that you can specify what happens when you switch to the menu page. You want to update. So in the case of the menu page here, if you're already participating in a race, it changes join race to race info, meaning that you're already a part of a race. So I adapt the UI. It's just not static UI. The content actually changes. Okay, now I'm going to shift over to security with these things, because there's some things I have to be aware of when developing the application. They're a little bit different. First of all, as I mentioned before, we don't have HTTP. We also have a different usage pattern than your typical web application, which I'll get into on the next slide. So the Java, as I mentioned, we're consuming Java EE services. The users do not expect to authenticate each time you launch your application. I think when I changed the template, we lost the words there on the right. So the first question to think about on this slide is, every time on your iPhone or Android device you launch your email application, does it require that you enter in your email address and your username and password in order to access it? No. It's cached something that allows you to log in, right? And with that, you'd hope that your applications are not caching your passwords and user credentials, right? Because phones are regularly stolen or lost. Most users use the same password for all of their accounts. So, and the same email address, which means that if your application is storing the names and the passwords in text, or even if they're hashed, once somebody has the phone, they can run through all of your accounts and get access to your Facebook account and Google account and everything else. So anyway, so you do not want to cache usernames and passwords so that you make the news. So how is a Cordova application different than your typical web application? And how, in terms of how the user uses the application. Well, let's look at our sailing application here. So, the application gets launched. 10 seconds later, the user clicks on the thing to join a race, or retrieves his race information. So the user quits the application, checks email, and motors out to the harbor. They get out there. They launch the application once again. They click on join race. It uses the information that was cached to send a message off to the server to say, I want to join the race. And then the user goes on racing for the next, hour and 35 minutes. Okay? And then after that, they decide to update the account or something like that. And then a couple of hours later, they view the results. So even if you were serving up the stuff from a regular web page, And this is where the mobile, a mobile web application is not necessarily a good fit, because if you had that HTTP session, the HTTP session is not going to last for 3 hours. You're not going to have that stuff cached up on the server for 3 hours, right? So that's a difference in terms of this model, is that it's very, how many times, you check your email, then you hop over and you check Twitter or something like that. So you're constantly hopping between things, and there's really no concept of a session being maintained with the server. And that brings up the next thing. For this application, and using the Java EE application, you really want to be able to use security, right? So you want to be able to use the roles, right? So you want to say, the race bean is limited to the skipper. So you want to use the declarative roles, right? So it goes from the Apache Cordova to the JAX-RS and then the EJBs, but you want the roles to be enforced for you. And so you might think, well, and I think in the WebSocket one yesterday, you edit your web.xml and you specify which are the restricted URLs. Won't work. Because remember, the pages aren't being served up from the server. There's no JSession ID. There's no HTTP session. So none of that stuff is being handled for you automatically. Okay? Now, you could do this if you're caching the password, right? This is a bad idea because you're caching the password on the thing, and then with every request, you're going through authentication again. So say you did decide to save the username and password. You figure that the users are smart enough that they're not going to use the same password for everything. Well, this means that every time you issue a request, you're going to include the username and password, which gives the person that's monitoring wire traffic ample time to analyze the traffic. The better approach, and I'm not claiming that this is the only approach for doing this. I mean, there's OAuth, there's other things out there that handle authentication, so there's many different ways. This is just how I tackled it for this presentation, to provide kind of like a template or a starting point for you, and to show you a better way of doing it, is token-based authentication, which I used a generated UID on the server side. So the user authenticates once using their username and password. This is done using POST, so that you can't capture capture it as easily. And then the server generates a UID, which the client then stores. Now we can, on the server side, we can expire the token after a certain period of time and force the user to log in. If the user logs in from another device, we could reset the token at that point. We have all kinds of decisions that we can make with that. If the token isn't valid, the user is forced to re-authenticate. Token authentication is performed before the web service is actually invoked. So before we even get to the web service, we've verified the token. And the other thing is to remember, which we don't have an option on the WebSocket stuff, is servers can log HTTP requests. So you don't want to put the token in the URL, because otherwise the token would end up stored in some server log somewhere. So if somebody gets access to the server logs, they can log into that. So one thing you might consider is to write a web filter which will intercept the request and perform logins, right? You'll grab the token out of the request and perform the login. And by doing this login down below, then the Java EE security will work downstream, right? Because your principals will be set up in the current session for the request. And then, that down below, I get the bean, and I do the, we're using our injection here, so we get the authorization bean, and we do the authorization underneath the hood to log in. So that's the code that's down below. This is the important code blown up so you can see it. This is a bad idea. And the reason why this is a bad idea is because every time somebody makes a REST call, you're going to go off to the database and check the credentials. Now, generally, if, the requests are going to be coming, so there's going to be bursts of requests, right? And so we don't want to be hammering the data, because the tokens, we can cache the tokens and know that if the token is valid, it's valid for a while. We don't want to be hammering the database every time somebody invokes a web service call in the application. So this is a really bad idea. So for the DBA will love you when he sees, there's been the user table is accessed, 10,000 times per hour. As every time somebody clicks on one of those menus, get me the list of races, it goes off and does authentication again. They're going to hate that. So the drawbacks is the authentication is performed on each request. The client must cache the credentials and resubmit every time. The container will repeatedly check the database, as I mentioned. The alternate approach, and this is very hard to figure out the first time, is you can use JASPIC, the Java Authentication API for containers. Not many people have done this, and it's something of a black box. The Java doc is pretty much equivalent to set name, and the Java doc sets the name. So that's in terms of reading and understanding this, it's pretty hard. Yep. So we're getting there. So the JSPIC pieces, we've got our servlet context listener to do the initial registration of the auth content provider. So down below, the server auth module is what actually does the work. And we've got these things all the way in between that are basically factories that create other factories that return factories for us. So you have to go through, if you want to implement your server auth module right now, you're going to have to implement all of those factories in order to return that guy. And I don't claim to be an expert on this API. This API, there's many things to this API. In terms of learning it the first time, finding code examples, what I did was I went out, checked out the Glassfish source code from repository, found their implementation of it, and started reading through to try to figure out, because you can look at how they're doing authentication, right? And you can read through that and figure out how they're actually doing it. So this is the initial web listener, which registers our first factory, which is that one. Then we register our other factory, which then produces this guy. We're almost to the part that actually does the work. Finally, we're to the part that actually does the authentication. And here, because we don't, this guy does not participate in CDI or anything else, we have to go and request our, which is a singleton bean, which I think I show, which actually does the authorization. Checks that gets the authorized bean, and that bean is connected into a cache, which has the tokens cached and everything else. So it doesn't have to hit the database. So what we're doing is we're specifying we're interested in the HTTP message, and we're looking up our own EJB that performs the authentication as code sample here. And then on the next block of code, this is the code that actually sets up our principles, so that all of our Java EE roles, declares roles, requires roles, all of that will be set up for us. And so up at the top, there's two things to realize. In the thing yesterday, we were talking about WebSockets and how do you authenticate, how do you deal with WebSockets? Because the WebSocket API on the client side, you don't have the ability to set the HTTP headers. So that means you can't set, the token, because I set this X security token to go back and forth, so I know that the request is, the authorization code. I include that in the token in the header. Well, we can't do that with WebSockets. So the only thing I can do here is I can either handle it in the on message, which would then I wouldn't be able to set up this stuff because I'm not at the point that I can do this. So what I do instead is something slightly bad until they have a better solution. Is I put the token in the included in the URL. This is going this in a production environment. This would be going using WSS, so it'd be going with a secured socket. So it's not that bad. You just would have to make sure that your server logs are locked down. And I look at it and I grab the token off of that, and that's how I authenticate the WebSocket, so that all the role stuff will work on the WebSocket stuff downstream. And then the singleton bean here, you can see I'm using the container managed concurrency because I want to make sure that this can handle multiple concurrent requests at the same time. I cache the token in a real implementation. This would be storing the tokens in Hazel, like in a distributed cache. So all of the nodes, so each node doesn't have to, every time a request hits a different node, the node doesn't have to cache it because, and any of those individual RESTful calls are going to go to different nodes in a load balanced environment. Right. So this is basically, just a sequence diagram showing you what's happening. We join the race, we check the token, then finally we invoke. After that succeeds, after authorization succeeds, then we invoke the RS endpoint, and then finally the EJBs get called with the correct role information, the Java EE security role information. Okay. So now testing. I'll kind of go through this a little fast. It's only 20 minutes late. So testing can be done on both JavaScript and Java EE code. So for the Java EE code, you'd use the Archillion. This allows you to run the container within your unit tests, and using the new JAX-RS 2 client-side APIs, you can actually test your Ajax, your RESTful web services in your Archillion tests. So it allows you to do automated tests where you fire up the container and then you have a client that talks and tests all of your RESTful web services. And then on the JavaScripting side, JavaScripting, unlike the JavaScripting frameworks, unlike the Java side, your unit test runner and your actual assertion testing framework are separate. NetBeans supports Karma and JS test. I like Karma thus far. And so you have your test runner, which basically runs a web server, uses the Chrome V8 engine underneath the hood to run your unit tests. You can even launch the web browser to run your tests actually in the Chrome web browser. So you can actually see it launch Chrome. And then you use Jasmine to actually perform and implement the unit tests. So in order to use Karma, you'd install Karma. Install the Karma Chrome launcher. So this, once again, is using the Node.js stuff. And then you configure NetBeans to use Karma, specifying the Karma installation, directories, write tests, and everything else. So this could be an entire presentation in and of itself as to how to use this. So this is where I say that your development environment is very important. So that is one of the benefits of using like the NetBeans stuff, because it ties everything together for you.
So then, like I said, next year we'll probably do a presentation more focused on how do you deploy it on Amazon. In the meantime, you're welcome to go create an account for free. And there's also a ton of tools on Amazon. It's actually incredible. And the documentation is awesome. It really describes everything top to bottom. So I invite you to check that out. I think next year, Java 1, we'll probably have a deep dive on how you actually deploy the application and the implications of load balancing. So coming in next year. And then, of course, once you have built your app, then you can go off and try to put it on the various stores, the Apple Store, Android Market, and so forth and so on. There will be a cost associated with that in many cases, so just be aware of that.
Okay, and kind of tying back, that's provided that we get accepted next year. Actually, as a part of this demo, we had grand plans for, actually, we set up an Amazon account with Wildfly on it with load balancing. And one of the demos we were going to do, but we don't have time for doing it, is to like fail nodes and show failover of like WebSocket connections and how you implement that. But that turns out that would be like a whole day training session. So it was kind of like, sounded like a great idea back in June. So we did set up the servers and everything for doing that. So best practices. So you want to, for REST, you want to use REST for the most part, and WebSocket only for full duplex bidirectional communication. The REST request should be not granular. They should be coarse grained, is what I meant to say there, which means that you want to return back as much data as possible for each one, because you don't want it hitting the server a million times. Get me the race. Okay, give me the list of race participants. Okay, give me the boats for those race participants. You want to return everything in one call, because there's going to be latency issues, especially on a mobile phone. And for this application, once you get a mile off the coast, they don't have cell phone towers out there. And for JSON versus XML, JSON hands down. In some cases, there's some support for binary data, but you can gzip stuff right now. Storing state mostly on the client. So this application, if you look for the source code through it later, you'll see that it's using local storage to store the data. And that is so that it caches it locally, because every time the application launches, you don't want to have to go out and fetch your data again, because you might not have a network connection. As I touched upon earlier, versioning is extremely important, because your users may never update your application. So they may take install your application once and then never update it. So as you're deploying new versions of your application up on there on the server, you have to realize you're going to have older versions of your application. So whether you do that with you have one server running the old server, and the load balancer looks at the incoming requests and figures out which server to run it to, or you implement that at the API level, there's many different ways of doing that. Finally, for security down below, I've shown you my token-based approach in this case. There's also other things that would require, you might want to, instead of forcing the user to create another account, you might want to tie into, the OAuth stuff. There was a session yesterday on OAuth. You might want to tie into the people's users' Facebook accounts, Google accounts, LinkedIn accounts, or support all of them. So that's where that comes in. Then in summary, so Apache Cordova provides basically a true standards-based cross-platform development environment. Java EE 7 makes this all possible. I can't stress that enough, that it provides a lot of infrastructure that you would have to write yourself. So, this is extremely powerful. You can use the demo code as a starting point. Yeah. So that's
I told you Elvis would sing. That's right on time.
Was that? Your phone? Did your phone?
Yeah, that was the phone.
Okay. Actually, I didn't know you could do that.
3 minutes ahead, so we're good.
Okay. So with
this is the last one. Yeah.
Yep. So this is the summary of some resources.
And this one's really good. This Cordova getting started one.
Yep.
Other than the fact that the app at the end doesn't work, that's the only.
So Tyrus is the reference implementation on the Java EE side. There's many things.
I forgot my Twitter handle, LE_FINO. And of course the 2 books, again, shameless plug, in the bookstore. You can find Ryan's books over there.
Yep, and I've got 2 more sessions. One this afternoon is on JavaFX versus HTML5.
A repeat of last year's?
Sort of.
Sort of.
Yeah, sort of. So this one actually, for that presentation, there's basically a version of this application written in JavaFX. So that's what that presentation will be touching upon, is looking at HTML5 versus JavaFX, because it's an FX presentation. So we'll be comparing the implementation between the 2 of them. And this all sounds pretty straightforward until you start dealing with some of the idiosyncrasies with the browser and all the rest of it. In terms of the different phone things, like the icons that, like the bars across the top, and the fact that one of the issues with this application was on the registration page, when the keyboard would come up for you to type in the thing, it would push the application up, right? So it would behave as if there's a scroll bar there, so then it wouldn't come back down. So there's all kinds of, because with the header bar up at the top, so there's all kinds of little idiosyncrasies. So yes, HTML5 applications are extremely easy to write and very hard to debug. Okay.
Any questions? So about 5 minutes.
Cordova versions. Is it possible to use Cordova versions without JNode because it's just so intimidating?
Well, to be honest with you, I know practically nothing about Node.js. So all you're using is the...
Thanks, everybody.